Hey everybody, so here's the second part of tutorial 4. So first of all, we've got just a very standard setup that you should recognize at this point. Up here we've got our world. It's attached to a handle so that we can manipulate, zoom in and out, holding down the Option key and look at things, and then reset to the camera view when we're done exploring that. We're sending the FR, which is the frame report when a frame is rendered. We're using that to drive the jit.matrix here. We've got a camera that's positioned 5 meters away from the center of the space. Hidden behind here, we've got a standard sound player that we may use later on. We've got a jit.bfg noise generator, so controlled random generator. We've got our standard list here of different types of noise that we can generate, and scale and offset controls so that we can drive that noise here, and also we've connected a button to the output of the floating point number boxes here so that every time we make a change it re-renders the noise. If you don't do this, then you either need to click the button explicitly each time you re-render your noise, or connect your jit.bfg to the frame output so it's constantly re-rendering. And dealing with a 50 value one-dimensional 3-plane matrix like this connection is fine. Re-rendering this simple noise every frame is totally fine. However, this is not what you're going to want to do as a general practice, because as these jit.bfgs get larger and larger, particularly if you're working with 2 or 3-dimensional noise matrices, you do not want the computer having to calculate those every frame. So this is why I'm showing you this approach, where you only calculate it when you make a change, and that's going to be much more efficient for our later use. And then down here, well, this is just a jit.p window that I have. I'm passing the image through into the color input. That's exactly the same as running a separate cable to the color input. And in fact, it's probably better to run a separate cable because you can see when you make this cable, it's not obvious that it's matrix information because it's just a gray cable. But if you make this connection, it's automatically a dashed green cable, so you know you've got matrix info there. And then down here, we're receiving our frame impulse to push values out of this jit.matrix. We're filling this matrix. We're setting all values to a single value that we're then passing directly to the scale inlet of our jit.gl.multiple, allowing us to change the scale of these circles. Then we're also using that to control the rotation. It's a very small value. We wouldn't start to see that rotation until things got really large. And as someone asked me in class, and this is hopefully something that most of you have discovered on your own, when you're manipulating these message boxes, the value that you click on is the one that's going to change. So if I want to change the thousandth, I click on the 2, and now I'm changing it in thousandths. If I want to click it in hundredths, I click on the 5, and now I'm changing it faster. If I want to click on if I want to change it in tenths, I click on that 0, and now I can change it. And if I want to change it in integer values, I click on the integer, and that's of course too big for what we're doing right now. So the further to the right I click it, the finer my adjustment is. And this is actually a really beautiful interface. It's much, much better than anything else that's out there in other software in terms of being able to change the type of control you have over values. So what's going on here? So we're controlling the rotation, but it's such a tiny amount it might as well be 0. We're controlling the scale, which is quite visible, and we're also using a jit.gen here just to take the normalized value, break out the x, multiply that by 3, and treat that as the x here. So basically spreading spreading these circles out from -3 to +3. And one of the things about working with a single dimension, right? We're working with a single dimension here. We're just doing 50, right? So 3 values stored at each of 50 locations. So when we swizz out x and multiply it by 3 and make it the x of our position, we're spreading these things out over the x dimension. Now, technically, y and z would be 0 because we just have a single dimension matrix. But when you're working with a single dimension, actually y and z are all identical with x, which is why if you don't swizz at all, you get this diagonal, because x, y, and z are all normalized 0 to 1, even though we're only in a single dimension matrix. So that's about to change in this tutorial, and it might clarify if you're struggling with the concept of swizz a little bit, it might clarify things for you. And this 3 is changeable. I can call this width, and the nice thing about our convention of putting things all in capital letters in class is we can see instantly that this is something that we made up. I could have called it wide. I could have called it widey. It doesn't matter. Wide, or width is what I want it to be. The other nice thing about putting this all in caps is that it's not going to autocomplete to something else. And so now this becomes changeable. How do I set the initial value and make it changeable from outside? I use the param object, and I say param width has a starting value of 3. Yeah, and it stretches it out. So I'm using I'm creating this is essentially a variable name. I'm creating a variable name called a parameter. And with the param object, I'm defining the initial value. Also, what the param object does is allows me to access this value from outside of my jit.gen. So I can now, as you can with any object, I can make a message and say width $1. So now what was previously trapped inside my jit.gen is accessible to me from outside the jit.gen. And you can do this as many times as you want with different parameters. So the other thing that I want to do in this tutorial is start to look at multi-dimensional matrices, in part because they're really useful and really interesting, and also in part because they make this whole notion of swizz a little more accessible, and why we're swizzing out and then vecking back together these different dimensions. So let's take our jit.matrix 3 float 32 50, and let's give it, instead of making it 50, we'll make it 50 by 50. And give it some new values again. And then instead of just swizzing out the x, we're going to swizz out the x and the y. And add a new param called height. And put that into the y. And we're going to say param height 3. And now we're getting 50 by 50 grid of circles. And so each one of these is a jit.gl.grid shape. Each one of these is going to change size as I modulate the size, and the colors are being mapped onto the individual circles. I can also take my jit.bfg and make it two-dimensional. And we've seen this before. This gives me an image here that is again spread out on my objects. I can change the offset. Now, but look what happens when I change the scale. right? With only one scale value, I'm only changing the X scale. I'm only changing the width. So if I want it to change in the X and the Y, I would need to add a second $1 here. Now it's zooming in and out. Why is that? Because I've added a dimension, right? Before, I just had a line of values. I had 50 values. And so I only needed one scaling to make it wider or narrower. But now that I'm moving up to 2 dimensions, I need 2 scales. And technically I need 2 offsets as well. Like so. Even though I'm still only offsetting it in X, but I have the possibility of offsetting it in the Y dimension. Like so. So now that I have a 2-dimensional matrix, I'm getting different values out of Swizz X and Swizz Y and packing them back into my vec. And so I can manipulate them separately. My width now controls only modifications of the X, and if I add height, that will control only modifications of the Y. So I have a much, much richer control system. So these inlets, in1 and in2, what are they all about? We haven't even needed them yet. So let's take a look at that. So I can actually take, for instance, this color information here, and rather than dealing with normalized values, I could make a jit.gen, and I can actually use the matrix coming in one and do something with it. This is red, green, and blue. And then the other thing I like to do is just colorize these to make it clear what's what. And you can see my color picker is a little bit different than your color picker because I'm working with a slightly newer version of the software. So I'm swizzing out my red, my green, and my blue, and then I can vec those back together and send them out my outlet. So why would you want to do this? Well, for instance, this gives you a different type of control of the image. So I can cut my redness down by half in the image. And I'll put another jit.p window here so we can see what actually happens. See, this image is a lot bluer than that image because in my jit.gen I've reduced the redness by half. And I can also, for instance, take the greenness and make it both the green and the blue. So this is going to give me a entirely, the entirely turquoise image with some red highlights. So you see, you don't have to work within a fixed palette, and there's a tremendous, of course, range of things that you can do once you're in the jit.gen to manipulate your color information. So let's say that we like that, we're happy with that. What else can we do now that we know these inlets do something? Well, here's the really exciting thing. We'll take out the redness of this image, so we'll do 0. That helps us think of this is the redness of the image, and we can label that. Right, the redness of this image is going to become the Z of our circles. So now take a look at what happens. I've got a landscape, 3D landscape. Why did I get a 3D landscape here? Because Z is now being changed by the redness of the image. So all of the crests in my landscape are where the image is reddest. And you know, we can do this any way we want. We can not use the red, we can use the green. Or, well, in this case, the blue, because I happen to do Swizz too. So, right, so now the blueness of the image is what's going to affect the height of the landscape. And that's, you know, that's pretty amazing, right? We've got a whole sort of game-like interaction now. And you know, quite beautiful range of possibilities. And of course, then this all is interacting. So my width is still controlling my width. And my height is still controlling my height, and my scale is still controlling my scale. So I've got all of these factors interacting. And you know, now that we've got this, we can continue to just make interesting connections and changes to the material. For instance, right now we're working only with one scale. We're working with a uniform scale of 0.13. But that is not necessary. We can take a jit.gen and have the scale correspond to, for instance, the redness of the image. So let's alter the scale of these using, say, the redness. And again, Swizz X and Swizz 0 are exactly the same. I'm using Swizz 0 just to emphasize the fact that this is color. I'm going to scale them equally in all dimensions based on the redness of the image. So the redder a circle is, the larger it is. So take a look at what we're getting now. We can see that we have a 3D landscape because in here our blueness is controlling the Z position of the circles, and we've got a landscape that sort of looks like a halftone grid because the redder a circle is, the larger it is. And, so, and again, all of our controls are still fully interactive here, except for this one. This one no longer applies because we're no longer even passing this matrix into the scale, so we can delete that. So what else can we look at here? Well, let's add a third dimension. And now we have normalized X, Y, and Z values. And I can just multiply this by 3 for the moment so that we can see it creates a cube of circles. Right, can you tell that this is, we're now within a cube of circles? And so anything I do to the width and the height still affects those parameters, but I have an additional parameter now of depth. So I can add depth here. And I've got this cube of shapes. And I can still affect the coloration of it, but now I actually have 3-dimensional color, which is really, really interesting. And the way to see a three-dimensional color matrix is to try the different offsets. I can offset, I'm going to reset this, I can offset it vertically, I can offset it horizontally, and now I have a third option, which is to offset it in the Z plane. Right, so the change is actually moving towards me or moving away from me, which, if we look at the two-dimensional version of it, is kind of hard to understand what's actually happening. It just seems to be swirling. But if we look at the three-dimensional version, we can clearly see that we're moving through a three-dimensional noise space, backwards and forwards. So this is really a really interesting capability of 3D noise. I also just want to quickly look at back to our friends sine and cosine, because they allow us to take this cube and turn it into something more circular. Right, so I'm ignoring y for the moment because my x is determining everything. And of course, a circle doesn't have to be a circle, it can be an oval. So I can still use my height variable here. And actually, this is now more like size. My height is only affecting the y, so you can already see that it's an oval. And then, as one of the students discovered last week, by adding a value here, we create rotation. Because it's in all caps, we know that I just created that. And we now have a rotation parameter. And everything is interacting. We have height, we have depth, we have rota. If we wanted to reinstall width, we could go in here and add width back to here. But now it's the width of our circle rather than the width of our grid. W-I-D-T, yeah. So things are getting pretty crowded here, so let's just encapsulate some stuff. I'm going to encapsulate my color, edit, encapsulate. P color, and then I can take this whole thing and edit, encapsulate, P position, and there. Things are much neater and more organized now. And still, I could have color information influence aspects of position by taking input 2 and, for instance, adding that to. Let's just see what happens if if I add the color to the height. See if that does anything interesting. Go into P color, make a modification to our color. All right, that does do something pretty darn interesting, which is we're using color to change the height of the images. Wow, I didn't even really kind of expect this interesting a result. It's quite compelling. I'm not sure why I'm getting such a, let's try some distorted noise. My scale is low, that's why. I'm getting a very uniform. Here we go. So yeah, with a low scale, the noise is going to be, is not going to have a lot of detail in it. Right, so this ability to patch one type of information into another because we can use the inlets of the jit.gen is really powerful. One thing that happened here when I encapsulated, which is worth noting, is take a look at this. I'm just going to pull this out of the way. And segmented patch cords means if you click on a patch cord while you're drawing it, it puts bends in it. That's how you can keep things from overlapping if you don't want them to overlap one another. So inside this encapsulated p.pos, right, I encapsulated a jit.gen, but now we see, right, we've got things inside other things. So this jit.gen is inside of this p.pos, which is inside of our main patch. And as you work more and more complexly, instead of spreading out across the screen, you're going to spread deeper and deeper into sub-patches. Here, this is a nice opportunity to use a send. Just take all of these. So I option click and drag to select all the chords, and I can just move them. And I'm sending it to pcont, which is just my little abbreviation for position controller. And here I'm going to receive pcont, and that just makes a wireless connection. We can start to clean up our interface by option clicking and dragging over objects and patch cords and saying hide unlock, object hide unlock, Command K. So now when I lock my patch, that junk disappears. Isn't that nice? That starts to make your patch look more like an interface for something. And you can do this with everything. Option, click and drag over all this stuff, object, hide unlock, there it is. And then when you lock, it just goes away. Right, so you could turn this whole mess, you can take everything that you don't absolutely need to see, Command K, and when you lock your patch, it disappears. Any control like the ones inside our P color that we want to break out to the outside, we can make send and receives for them. Call them C offset and C scale for color offset and color scale. And then out here, I can just do send C offset and send C scale. And now these are going into my color generator and controlling that. Without me needing all those messy patch cords. So I'm creating a much simpler control interface, if you will. If I like these values and I want them to stay, how do I get them to stay? That is with the loadmess object. So any value that I want to preserve for later, I just type into the loadmess. So loadmess 2.4 will mean when I close this patch and reopen it, this value will be reset to 2.4. So when I open the patch, it would ordinarily be 0, but loadmess will make it be 2.4. And this could be loadmess -1.6. Now here we are, we have this nice neat patch and we're making it messy again. So there's two things we can do about that. One, we can option click and drag over the objects and say Command K hide on lock, and that gets rid of them, but they still function, they're still there. Or loadmess can take multiple arguments. So we can loadmess 2.4, -1.6, and we can go through and loadmess all of the values we want to preserve here. 4.19, 57.663, 1.47, and -0.093. Where did I get all these values? I'm just reading them out of my own boxes here, right? 2.4, -1.6, 4.19. These are all the values I like. I want my patch to start here. And then we learned the pack object, so we can unpack all of these things. How many are there? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So unpack is just like pack. It has the C in it. We use PAK pack. This is unpack with a C in it. And we can send all these values like so. And we've created a very simple way to store and retrieve a whole bunch of stuff. And of course, option click and drag over it, Command K to lock, it all goes away. So we change these values to any other set of values, and then if we double click our load mess, everything goes back to where it was. And of course, every time we open our patch, these values will all be set by the load mess. We can hook up a button to a load mess so that we have a reset button. So we change stuff, change stuff, change stuff, change stuff, reset. And of course label that reset. So now I'm up to the very, very last thing, which is just a handy tool, which is called attrui, pronounced either attrui or attrui. And you connect this to any object. And when you lock your patch, every possible attribute of that object appears in a big giant list. And this attrui you can connect to any object, and it will give you all of the various ways in which you can manipulate that object. So if I want to change the position of my camera, I've connected this one to my camera. I'll make this visible again, and I can shift camera position. Now these values also do not save with your patcher. So you need to be a little careful about using the attrui, because you will still need to load mess into your attrui in order to save values. And with the attrui, you can just load mess the full list. So 0, 0, 10, if you want that to be your starting camera position. When your patch opens, it will automatically load mess to 0, 0, 10, and you can of course put a camera reset button. And that's going to bring your camera back to the starting position. One thing I would leave you with is, unless you really need it, don't do a three-dimensional matrix of jit.bfg, because it really, really slows things down. Look at how much faster our response is. You know, it doesn't. You could do 20 by 20 by. You could do a three-dimensional matrix with a small third dimension. That's still going to be pretty responsive and pretty interesting. But as soon as you go to 3 fairly large dimensions in the jit.bfg, the computer's central processing unit, the CPU, really has to work super hard and everything slows down. All right, so enjoy that stuff. Make sure to build all of this as a starting place and then begin to modify it and play with it. One, to ensure your understanding of it, because until you modify it and play with it and break it and fix it, you don't really know that you grasp the material. And secondly, because that's where you're going to be able to discover the creative possibilities of it. All right, well, have a great week, and I'll see you in class, or if you're just watching this on the internet, thanks for your comments, and I'm happy to discuss with you any points that you're confused about. Students in particular, please email me with questions, and I will be back with more next week.